This podcast is brought to you by ProcessBarron. Handle everything better. Welcome to Powering the Process, the podcast focused on the real work behind industrial manufacturing. Each week, your host, Jen Little, digs into the systems, equipment, and strategies that keep plants running efficiently. From everyday operational challenges to emerging engineering solutions, we're here to share practical insights that help you keep your process moving. Let's get started.
Welcome to Powering the Process, the show where we uncover stories behind the industries that power America. Today we're talking about steel, the backbone of modern infrastructure. From bridges to skyscrapers to vehicles and machinery, steel keeps our world running. But producing steel is no small feat. It's a demanding process that requires precision, durability, and efficiency every step of the way. And that's where ProcessBarron comes in. Our team designs and delivers solutions that help steel plants operate at peak performance, handling extreme heat, heavy loads, and complex airflow systems to keep production running smoothly. In this episode, we'll explore how we support the steel industry, why it matters for America's growth, and what it takes to keep these massive operations moving forward. Today's guest is Joe Waite. He is Vice President of Air Handling and Material Handling Products. Joe has been with the company about 22 years, and over that time, he has served as estimator, sales manager, regional sales, sales director, and now he is leading that group. So welcome, Joe. So glad to have you.
Thank you very much. Glad to be here.
All right, Joe. So we have a series of questions presented from people, and they really want to know how ProcessBarron fits into this world of steel. Okay. So why do you think steel is considered the backbone of American infrastructure?
Well, that's a great question. Steel is, the steel industry is basically in everyday parts of our life. Everything that we do has to do and is involved with steel. Any production we have, any products that we have, it's made at a facility, and this facility is made from steel. So it could be your power, it could be the car you drive, it could be the stove. Everything is made from steel. So the economy is actually very indicative of how well the steel industry is doing.
So what industries rely most heavily on steel today?
So great question. The automotive industry is a very good indicator of economic conditions on the steel industry. Anything to do with power, anything to do, again, with any of the products that we do every day, that we use every day, such as your stove, your refrigerator. If you're driving to work in your car, obviously, if you're going to a commercial office building, the entire building is made of steel inside. So everything that we do pretty much has to do with something to do with steel.
Right. I think a lot of times we just go through our days. We don't think about where everything comes from.
That's right.
We just know we have it. We go to a store to buy it. Mm-hmm. But nobody really thinks about the manufacturing side of that. So thinking about the manufacturing side on the steel mills, where does ProcessBarron fit into that? What exactly do we provide to steel plants?
So we provide heavy, custom industrial equipment, all made from steel, by the way, that goes into the steel producing facilities, mainly on the back end after the steel is being produced, smelted. We actually provide most of the equipment that drafts the gases out of the furnace, that goes out to the bag house or precipitator and is cleaned before it is released into the atmosphere.
So how do the systems that we engineer, manufacture, and install, how do they improve efficiency at a steel plant?
So as part of the steel making process, the way they smelt it, you have to be able to draft the gases off. So there's a process where they heat the steel up and they melt it, and then they make the ingots, and then they make it into the final products. Well, what we do is we supply a lot of the equipment, the fans, that will actually draft those gases out. So depending on how they draft, the efficiency of the fans, whether they can remove the particulate out of the canopy, all of those things help the steel making process. So if it's not done correctly or inefficiently, you can have problems there. Some of the problems that you see are the steel industry is heavily regulated, like a lot of industrial facilities, and the emissions are very strict. And a lot of the equipment, again, that we supply, that we pull the gases out through our fans, through the ductwork systems, through the baghouses, we stay within compliance of a lot of these government regulations. And if we don't, these steel mills can't operate properly.
Well, okay, so over the years, can you share one particular success story at a steel plant? Is there something that comes to mind?
We've got a bunch of them, actually. There is a steel mill in Mississippi, a few hundred miles from where we are right now, that had some horribly inefficient fans. And what I mean by that is a fan is designed to draft a certain amount of gas out. Well, these fans were operating in a very inefficient manner. And what I mean by that is they use a lot more energy and power than is necessary. They also would prematurely wear out from the particulate. So what we did is we came in, we analyzed their system. We actually did some performance testing in the field. We determined that the fans were not optimized. So we came up with a project and we actually optimized the fans. And what that means is we put in new design wheels inside the existing housings. And again, these are used to draft the gases out of the canopy to go to the baghouse. And it not only made the fans more efficient, it made the fans last longer because a more efficient fan actually wears better. So what does that mean? Well, it turns out that after the project, it literally saved millions of dollars a year in power for this particular plant. Huge success.
Okay, so explain that just a little bit more for everybody. So when you say the plant, because of their inefficiencies, they're so basically purchasing power. Mm-hmm. So explain the difference of purchasing the power and then how our systems can come in and make it where they actually generate the power.
So at a steel mill, they don't actually generate the power. They are strictly parasitic. They buy all their power from those facilities. Now, there are power plants around that are close by that we can help produce power more efficiently with them by doing some upgrades on some of their systems. But here, they have a demand for power that is one of the biggest of any plants. A steel mill is huge amounts of energy requirements. And if we can provide a lot of this equipment or upgrade this equipment to make it more efficient, then what that'll do is it'll reduce their demand on their power bill. So their biggest cost is their power bill. And if we can reduce that, it makes the steel cheaper. They can make more money. The plant runs better. And it's just a better way of doing things.
Okay, so what does it take when you're talking about concept to completion? What does it take to design and install the equipment for such a demanding industry?
Great question. A lot of times at a lot of these facilities, the customer actually doesn't even know what they need. We come in a lot of times as a company that has a lot of experience with a lot of engineers here, and we can look at a system and determine, that doesn't look right. You've got leakage over here. This piece of equipment is running different than this one. You have vibration. So we analyze a lot of these systems, and when we do, we come up and we determine that, you may have a problem here. And then a lot of times when we're talking to our customers, they can say, you know what, we do have some problems there. Can you help me? Boom, that's how a lot of these projects develop. So we can go in there, and once we identify some issues, we come up with a solution. And that could be replacing some worn out equipment. It could be doing some performance testing and then figuring out, this fan is operating in a bad place. Maybe we need to do something with that. Or it could be something as simple as a lot of these systems have multiple fans that are running in parallel, and they don't have to operate all of them at the same time. Well, sometimes we've discovered at some of these mills that the fan that is not online will free spin. and that's dangerous and can damage the bearings and do a lot of other damages to the system. We've created a new product called a safety brake where we can actually stop that fan from rotating backwards. So there's a lot of little engineered solutions that we can do. And it's not just fans. It could be dampers. It could be a new type of expansion joint with the expansion joint belt having a different type of material. And a lot of this too is coupled with the fact that we can do a lot of the field installation to actually make these improvements at these plants.
That sounds great, Joe. So do you see changes in the steel industry in the next 10 years? Where do you think it's going to be?
So I do. And the steel industry is probably one of the biggest indicators of the health of an economy. If there's a big demand for steel, and it's not just in America, it's worldwide because it's a worldwide commodity, and there's actually a lot of steel mills that are being built right now in emerging economies, Asian theaters, places like that. And the market is like the oil market. It all is intertwined. So if you see a lot of steel demand, the economy's doing good. If the steel demand is going down for a little bit, then there's some adjustments going on. So like right now, we have a little bit of excess capacity in the United States. And some of these mills, what will happen is they actually will be like, you hear the term peaking plants. The power industry utilizes that a lot where they chase the demand with power and they'll bring plants up and down. Well, the steel industry will actually sometimes mothball their plants in low demand times and then start them back up. So they cycle with the demand of the industry. But for the next 10 years, the economies of the world are going to continue to grow. And everything that we need is made at a plant, and the plants are made out of steel. So it literally is the backbone. That and energy are the backbones of our economy and our country.
So knowing that the steel industry does use those kind of practices, when we are looking at preventive maintenance, which is one of the things that, of course, we offer to all of our customers, what kind of cycle is that preventive maintenance on? I mean, for a steel industry, would you say, we're there once a year, twice a year?
Yeah.
Is it
Good
wait
question.
until they call?
Well, a little bit of all of that. Typically, they will have an annual outage, and like most facilities, and they come up with a scope of work, and then we'll come in, and then we will do the scope of work. And a lot of that could be just general repairs that we deal with. It could be replacement of equipment. It could be a lot of different things. But the steel industry, like a lot of industries, is notorious for having an occasional failure. Something breaks, something happened where they need emergency crews. And we come in and we do maintenance on that, or we do replacement of equipment.
Mm-hmm. So what do you think is the most critical piece of equipment in a steel plant?
That's actually a tough one because there's so many different pieces of equipment in the line that any one of them goes down could bring the furnace down. The thing about the draft system, because it's so heavily regulated, that's why they typically have multiple fans, and the multiple fans, they have redundancy. So if one fan were to go down, they can usually run on, say, a typical system has 4 induced draft fans, ID fans. They typically can run on 3 of them. So, and they do that because, number one, taking the furnace down is catastrophic, especially when they're running in good market conditions and making a lot of money. And number two, they do it because there's a lot of wear there. And if they do have a failure because of wear, they need to be able to operate the adjacent fan and keep the furnace online.
So what do you think is the biggest challenge for the steel industry right now?
Probably just the economic factors of the world, the economy, and the way the markets shift with the steel industry. For instance, if you've got a lot of infrastructure projects going, you've got big bridges, you've got skyscrapers, you've got a lot of things like that. The steel industry's bumping hard. They're going gangbusters. If a lot of that gets shuttered for a little while, well, then they'll back down. There's a lot of politics in this industry. And but the steel industry, again, is a good indicator of the health of the economy.
So what do you think is one misconception about steel manufacturing?
I don't know if in the industry that we're in, I don't know if it's a much different than most big producing plants, whether it's pulp and paper, whether it's cement, lime, steel. I think they're all pretty much the same. I guess probably the biggest thing that I can think of is the way the plants ultimately cycle. And sometimes they are down for extended periods of time and then they ramp back up. A lot of plants don't operate like that. A lot of plants are base loaded. They stay and they produce. These guys will load follow. They will cycle according to the economy, especially the big mines, the tagonite mines and places like that where they produce the pellets that make the steel.
Okay. So do you have a memorable project that sticks out? Maybe something just one of the best ones that we ever did?
Well, we've created a lot of very loyal customers in multiple steel mills, but one in particular was up in Ohio where we were going in to visit a customer. We had never done business with them before, and they had 2 EAF furnaces there. One of the furnaces had some issues with the gas conditioning tower. That's a piece of equipment where they cool the flue gas down before it goes to the baghouse. And they kept having multiple leaks and expansion joints. Well, we went up there and said, we've got an idea. We know how to fix this. And they're like, we've tried everything. We've replaced them. And I said, well, don't replace them. We need to build an expansion joint and leave what's in place and build one around the one you have. Let that be a buffer, pack it full of insulation, and then we'll be able to capture all the gas and keep it from leaking. And he's like, man, I don't know if we can do that. But I showed him some references. We did it. They tried it. They bought it. Unbelievable success story. This probably happened 10 years ago, and they have not had to do anything to those expansion joints since.
Awesome.
So and we have a very loyal customer now, very loyal because of that.
All right, Joe. So what do you think is the most common maintenance issue in the steel industry?
For the products that we provide and service, it's definitely the induced draft fans pulling the gases out of the furnace. There's a lot of particulate in the gas stream, and they do a lot of damage, erosion damage to the fan wheels. So that is a very common thing that we go in during annual shutdowns and we do repairs. We'll either replace a wheel or we'll do weld repairs on there where we build up the metal that has been eroded away. Very common. So from what we supply, it's mainly the draft system. It's the fans.
So just, kind of picking your brain here, what is one thing that you wish more people understood about steel production?
Probably not as much about the steel producing, but what people need to understand about the steel industry is, I've reiterated this before, but it is literally the background of our entire economy in our country. The steel industry, the United States, was built based on that. Andrew Carnegie in the 1800s perfected the steel process, and he sold that to J.P. Morgan at one point, and then back in the early 1900s, and U.S. Steel was created. The steel industry in the United States is one of the reasons that the Allies won World War II. I mean, it is literally that important that we could produce. And from the energy that we have and all the steel facilities that we can make, we created the greatest economy and GDP in the world. And steel had a lot to do with that.
So if you could sum it up in a few words, what ProcessBarron's impact is on the steel industry, what would that be?
So we have made it our mission to make sure that a lot of our steel producing customers have good, reliable equipment that we supply, that we can come in and we can provide maintenance on them, and we can make sure that they continue to operate and run so they can be the backbone of this country.
Thank you, Joe. Thank you for joining us today. It has been a pleasure, and looking forward to the next one.
Thank you very much. Appreciate it.